Hello everyone, let's discuss a Leetcode problem, and this is one of the problems from blind 75 list. And this is a very interesting problem and a very conceptual problem. So after solving this problem, I hope some of the concepts like Inorder, Preorder, Traversal would be like crystal clear to you. So at first, this problem may seem a little bit challenging, but over the steps, once we describe it or once we explain it, it will be a lot easy for you. But before I start, I would suggest everyone, like before I start solving it or share my thoughts about solving it, I would suggest everyone to think yourself. And I would say like there's a lot of chance, I have expectation that you yourself would be able to think about it. So let's talk about the problem description. So we are given two integer arrays called preorder and inorder. Okay, where the preorder is the preorder array provides the preorder traversal of the tree, and the inorder array provides the inorder traversal of the same tree. So we are given two arrays, so two orderings, and using those, one is the preorder ordering of the tree, and the other one is the inorder traversal of the tree. And using those two arrays, we have to create the original binary tree. So for example, let's say for the first example, basically you are not given, this is the binary tree, but at the beginning you won't know about this, like you can visualize this. So the only thing that you were given is this array and this inorder array. And using these two, I have to finally output this, which is basically the binary tree representation of this. Okay. Similarly, if you have, suppose in the second example, you have just one node. So basically the tree is going to also have just one node, that is the root node. So this problem, before solving this problem, I think if you have idea about the preorder traversal and inorder traversal, I would suggest everyone to think about it and what information you can get from a preorder traversal. Just think about it. If you have a preorder traversal, can you tell me what is the root of the tree? If you have an inorder traversal, what information do you have? And combining those two information, what do you have? And also you probably need some to ask the interviewer about some of the edge cases or clarify things. Suppose one good question might be like, are you sure that the preorder and the inorder both are like have just unique values, right? Because if they have duplicate values, that makes things sometimes say a little bit complicated. So suppose if the tree has like two of the same values, and then you somehow know that the root actually consists of a value 3, in that case it's a little bit challenging to think like which 3 is going to be the root. Also another question might be like, are you sure that the inorder and preorder traversal both have correct thing? Like that means the input is always correct. It might be the case that with the wrong input, your preorder traversing has something that some value that is not present in the inorder traversal. In that case, it's very difficult to find that thing out. So we have to ask the question about this. And if the preorder is guaranteed to be a preorder traversal of the tree, and the inorder is like they're the correct representation of the preorder and the inorder thing. So think about a bit, and then let's come back and discuss the thing together. Okay, so I hope you have put some thoughts about it. Probably some of you have got the whole thought. Some may have partial thoughts, but that's a great starting point. Others, if you haven't found anything, that is still fine. That's still fine. Let's try to solve this together. So we know that the inorder traversal of the tree works like this. So it's like left subtree, right? So it's left subtree, and then root, and then right subtree. That is what we achieve in inorder traversal of the tree, right? But the preorder is like you first visit the root. You first visit the root and then you visit the left subtree and then you visit the right subtree. And finally, this is going to be the ordering, right? Okay. So we know that. Okay, so let's say our input here is this is the Inorder array, right? So let's say this is the I start index, something like this, and I end index. Okay. So this is the Inorder input, and this is the preorder array. Both of them obviously are going to have the like same number of elements because it's the same value, just same values in two separate orders, right? Two different orders. Sorry, this is p. So the index is p start and p end. Okay. Now, can we say that this is going to be the root of the tree? Can we say that? Obviously, right? Because in the preorder ordering of the tree, the first node that you visit is the root, right? Okay, so that's a great information, great piece of information. So let's say here in this example, it was say 3, 9, this was the Inorder thing, 3, 9, 20, 15, 7, this was the Inorder thing, right? And the preorder was 9, 3, 5, 20, and 7. This was the preorder. Okay, so from this, we can say that 9 is the root. We can say that, right? Okay, that's a great starting point. Now, what else where else we can find this information? Obviously, I want to create the left subtree and right subtree. I have found the root. That's an awesome starting. Okay, so another thing that we know is the rest of the things are like left subtree and the right subtree, right? In the preorder thing. But the information that we don't have is, suppose this portion, let's say this thing has the ordering of the left subtree and the right subtree. But the thing that we are missing is where does it divide? Like where is the left portion? Where does it divide? Now this piece of information can come from the Inorder thing. Let's think like we know that this is a root and we know that all the values are unique. So can we identify the index of the root, the same value in the Inorder traversal? Can we say that this is the index, this is the root? Yes, obviously. So in that case, for the Inorder thing, we can say this is the left subtree in representation and this is the right subtree representation, right? That's awesome. Okay, so one thing, like once you know the node from the preorder thing and you created the node, immediately what you need is you need the index. Suppose here the index is say 1, right? In this array, you need the index of the same value in the Inorder traversal. How do I find that index? Obviously, we can start reading, but that's not very efficient because every time we have to do like n, we may need to do like order of n reading, right, to find the index. Instead, why don't we just do some pre-processing? So yes, we can use a hash map. So using the hash map, I can just, so this is the Inorder map. So Inorder map or something like that, Inorder map, where I will put the values here and the index here, right? So suppose 3 will have an index 0, 9 will have an index 1, 20 has index 2, 15 has index 3, and 7 has index 4. Okay, so from here I can just find out, okay, index is 1, right? So now this is actually precious piece of information. Now I know that my left subtree size is 0 to 1, right? So can I say that length of left subtree is equals to like I start, right? I start, say, let's say this is the like root index. I found the root index. So it will be from I start to root index minus 1. Can I say that? Or just let's say, let's do this. The length of the left subtree is going to be root index minus I start. Can I say that? Yeah. And length of the right subtree is going to be I end minus root index. Can I say that? Yes. So here, can I say that, oh, okay, my left subtree length is 1 and right subtree length is 3. Can I say that? Yeah, so once I find that, so first I find the root from the preorder traversal, then I find the index of that same root in the inorder traversal, right? And then I know that what is the length of the left subtree, what is the length of the right subtree. Now you see, can I just now say that, okay, from here we have like say 4 elements left, and from the preorder traversal, can I say that the first element is the length of the left subtree is 1, right? So this is 1. So can I say my division happens here? So this is my left subtree, like this, and this portion is my right subtree. So this is the division. Okay, so there is a thing. I get the root from the preorder traversal. I know that very well. I find the index of that same root in the inorder traversal, and then immediately this divides the inorder traversal into 2 groups. I know the length of the left subtree. I know the length of the right subtree. Then based on that length, I come back to the preorder traversal and divide it properly, right? Okay, so now we're done, right? Okay, now let's do the same thing. So let's say for the left, let's say do the same operation for, suppose now the trees are no longer, the subtrees are now the thing. So I have to do this. And for the left subtree, the inorder traversal is going to be, like this, and preorder is going to be also 3, right? For the right subtree, the inorder is going to be 20, 15, 7, and the preorder is going to be 5, 20. This comes from this, right? 7. Sorry. Okay. Now I just repeat the same thing. Suppose for the left subtree, I go to preorder. I know this is the root of the left subtree. That means 5 is here. Is it 5? Sorry, it was 15 actually, right? Sorry. So 15 is here. This is 15. Okay, so I made a mistake here. Anyways, what happened is I just mixed up preorder and inorder, but that's fine. Like I am creating actually a different tree. Right? The root of my tree is 9, right subtree is 15. So I just swapped these 2 arrays. I'm not sure if it's going to work because the orders are going to be different. But anyways, this is the same idea I'm going to apply. Okay, so let's try to code this thing up. Okay, and another thing I missed, the final thing. So when do I just return these nulls, right? Obviously, the nulls, I return the nulls if for some tree I start is becomes like the start index becomes greater than the end index. In that case, that's not that's impossible, right? And in that case, I know that the tree is now empty, so I return null. Okay, so we have a function here, but let's change this function a bit to a helper function, and that will actually accommodate everything that we need. So we'll have a preorder and inorder array, and in the helper function, we will also have a start for the preorder, start index for the preorder tree, and end index for the preorder tree. Okay, and then if I start greater than I end, then I return null. That means it's an empty tree. Otherwise, what I do is let's also initiate a map where I will keep the indices of the in-order thing tree, because we will need to find the indices of the root, right? So it will be value again as the index. Hash map. Next, run a for loop in the in-order tree. Actually, I have to do this here, because I won't run this hash map again and again. And this should be a global hash map. Okay, so for I equals to I'll fill the hash map with every value and its corresponding index. Okay, so now this map has all the in-order values and their corresponding index in the in-order array. Okay, actually I have solved this before. I'm trying to just solve it again. Okay, so there goes it, and then what I have to do is from the preorder array, I know that the first element is going to be I can create a root. I know that that is the root of the current tree that I am trying to build, right? And the index is going to be p start. The first element, the starting element, is going to be the root of this tree. Okay, next what I have to do is int say root index. I want to find it from this map. Okay. Okay, so there goes the root index. Now I have to set a left. I will call this function build tree. Again, now just on the left subtree. So I will pass both of these. But the thing is now I will pass only the left subtree. So you see that my left subtree in the preorder list is going to start from the next index, right? The first index went into the root. So from the second index, and p end. What is the p end? Okay, so let's do like calculate this first. Or let's do this. Let's say left length. That means length of the left subtree is going to be, I know the root index in the Inorder, right? So it will be root index minus I start, right? And the right length is going to be I end minus root index, right? This is exactly what we had discussed here, okay? So now I know the length of the left subtree and also the length of the right subtree. So now I am taking only the left subtree portion for the preorder. It starts from the second index and it goes all the way up to start plus left length. Okay, and for the Inorder tree, it starts from the start point, I start, but it ends just before the root index. So it's like root index -1. Okay. So there goes the function call for the left subtree. For the right subtree, let's do this. And then it will start from this, right? And just we start plus left length +1. Yeah, actually, I don't need the right length. I can just take the, so there, here is where the left subtree ends. And here is where the right subtree starts, just after that, right? So you see there's a division, right? Here is where left subtree ends, here is where the right subtree starts, or just here in this array. By the way, these might not be a correct example because I messed up with the pre and the Inorder, but the idea still remains the same. So I'm not sure if we can create a tree out of this, but the idea remains the same. Okay, so we start plus, and for the Inorder tree is going to be root index +1, starts just after the root and ends at I end, the end of the tree. Okay, and finally I return root. Okay, done. Now I have to call this build tree. I have to pass the preorder, initial preorder, post-order, and okay, and the initial index is going to be 0 to preorder dot length -1. That's the last index. And for the Inorder tree, it's going to be 0 to Inorder dot length minus 1. Okay, so I'm not sure if every syntax or if there is any type or something. Let's try to see if it, okay. So, okay, so I have to define a left length. I actually don't need a right length, because once I have the left length and the indices, start and end indices, I can just calculate the right. That's what we did here. Okay, so I have one parameter less. Yeah, so this is the starting parameter for the right subtree in the preorder, and this is going to be also the end index in the preorder. Okay. Okay, so let's see what is the time complexity of our solution. So we created a map, right? We created a hash map, and then we filled it up. If the tree has like total n nodes, then this is order of n here, filling up the thing. And then we recalled a depth first search. You see that in here we have like visited every node just once. So in total, we have visited like n nodes, is order of n. Okay, and so overall the time complexity is going to be order of n, visiting each node once and also filling up the map. The space complexity, you see here, we have a map here, right? So that's order of n. Let's remove this time complexity thing. So we are talking about the space complexity now. So order of n here, the map uses n space, and also this is a recursive call. So you see we make recursive calls, right? So it's recursion, so that means we have to deal with call stack. What is the maximum size of the call stack? So we know that if every node is actually called once, there are n nodes, so the call stack can be at most of size n, right? Okay, so the space for the call stack is order of n, and then for the hash map is also order of n. This means the space is going to be also order of n. Okay, so that's it. Thank you very much for watching.